Hello and welcome back to another LeetCode video. This video we're going to be talking about the climbing stairs solution. It is a LeetCode easy problem, and in this problem we want to find the number of steps it takes going by 1 or 2 each time to add to n. So this is how I look at this problem, and for those of you with a mathematical background, you'd be able to notice that this is indeed the triangle numbers. The solution is the triangle numbers at, of course, n. So the triangle numbers are the Fibonacci numbers, and how you calculate the Fibonacci numbers is by taking the number of solutions, the Fibonacci number at n minus 2, and adding that to the Fibonacci number at n minus 1. So n minus 1 plus n minus 2. And we do this recursively. So the brute force solution is actually not too different from the optimal solution. We simply just use dynamic programming in the optimized solution to reduce the number of recursions by saving the previous computations in an array. But how I do this just off the bat, knowing that the solution is the recursive solution at n minus 1 plus the recursive solution at n minus 2. So climb stairs at n minus 1 plus n minus 2. Obviously not checking for the base cases here, but we should probably implement that first. I mean, I sometimes just go right to it, but we need the base cases that are given here. So when n is equal to 2, right, you can go one step at a time, twice, or you can just do 2 in one shot. But the answer is given to us here. So if n is equal to 2, we just return the output 2 in example 1. If n is equal to 3, we return 3. Actually, I don't know if we need this third base case, but I know we need 1. So when there's only 1, we can only do one step. And the constraints are n is between 1 and 45, so we don't need to check for 0 or anything else. So this right here works. In cases where n is greater than 3, then we use the recursive solution. And for example, 4, if n is equal to 4, then it's climb stairs inputting 3 and inputting 2. So that's 3 and 2, so that's 5, which is exactly the triangle numbers. Okay. To visualize what the triangle numbers look like, they look something like this, kind of like a stack of cards. Okay, so at n equals 1, n equals 2, n equals 3, and n equals 4, there's 5 solutions. So returning this recursively should pass the base cases. You can prove this mathematically, but computationally this is not sufficient because it's too slow for large numbers of n, because we recurse all the way down from, let's say, n equals 30 down to 29, 28, and for each one of those cases we also keep recursing. So recursing, I wouldn't tell you how to visualize it, but there's a lot of calls here, and how we do this optimally is using the dynamic programming technique. And in the dynamic programming solution, simply we initialize an array with all the solutions up to n. So it's an array of length n, and we fill it with 1. And instead of recursing and just not saving the values, we can take advantage of this array doing this in a loop, we loop over each one of the elements, each one of the n elements, and whenever we compute the Fibonacci number, so let r is equal to, we don't even need to initialize a new variable. We'll just set array at position I equal to whatever the result was at the I minus 1 and the I minus 2 position. Of course, the sum of the two. So simply we just need to return the last element in the array, which is the n minus 1th element, and this is array at n minus 1. Okay, so this works for when I is greater than 2, when I is less than 2, there are some array out of bounds. So first we need to check those, okay, but then we need to do another step afterwards too that you need to do to make sure your program doesn't crash, and I'll show you what I mean. So if n is equal to 1, then we'll just use the base cases here. So return 1 if n is equal to 2, return 2 if n is equal to 3, return 3, and we can set the results, we can hard code the results into the return array. Because it builds on top of each other, we need to put the results here because we're not doing recursively anymore. So array at the second position is equal to 2, and the array at the third position is 3. Okay. Now we don't need to recompute these values here, so we can start at I equals 2, because we already covered the base cases here. Okay, so this passes the test cases and is the solution. There we go. So that is LeetCode number 70, climbing stairs.